So here in this video, we are going to concentrate on the application layer and the transport layer of the OSI model. Remember that each device here, PC1, PC2, and for that matter also our router here, they have this construction inside. Remember, this is just a model in order for us to communicate what is going on networking-wise on our devices. Our focus will in particular be on the transport layer, where we have the so-called port. We bring up to recap here how our web server is working. PC1 is making a request to PC2, where we have the HTTP server running. HTTP server will fetch the index.html page and serve that back to PC1. So I have brought up this new diagram down here, which is the TCP IP stack over here for PC1 and the TCP IP stack over here for PC2. In the middle here, I have the TCP IP stack that we will be contemplating for our router. So when PC1 is making a request over to PC2 to get a web page, PC2, our web server, is sending that web page back to PC1. What is actually happening is that on PC1, we have Firefox, for example, as a web browser, making a GET request over to our HTTP server, and our HTTP server will send the requested page back to our Firefox web browser. As we can see here, this is taking place at the application layer on both our devices here. This is application layer traffic. And in this case, what is being used here is the HTTP protocol. Let me bring up Workstation and I'll fire up Firefox here on PC1. Type in on PC1 the IP address of PC2. And here we have the test page that I have created over on PC2. You might have noticed that I have put in here a number 8000 after the IP address of PC2. And if you look over here, 8000 is actually the number that I have indicated here at the transport layer. This is the so-called port number. This is the port number indicating on PC2 where my HTTP server is listening for incoming requests from, for example, a web browser. So if I clear this a bit, in reality, the GET request from Firefox is going to port 8000. This is where my HTTP server is sitting, and Firefox itself is sending from a port number over here, which I have indicated to be 46,502. So the communication goes from port to port on the two devices, from a port from PC1 to a port on PC2, and back from that port 8000 to that port on PC1 up here. If we move over to PC2 and look at how we started HTTP Python server, look at this line here, serving HTTP on any interface, and the port is 8000. This is where our Raspberry HTTP web server is listening for incoming requests, port 8000. The port number can be changed, but right now it is 8000. But what if we move back to PC1? What if I open one more web browser session? This time I would like to get the web page from my Nginx web server. And there you have it. So how is it possible to run two applications at the application layer at the same time? How do our PC1 and PC2 know how to split the traffic between the two applications at the application layer. In this case, the two Firefox applications and the two web servers over on PC2. And this split or multiplexing, if you like, is done by the TCP IP transport layer port numbers. So you can see here that I have added that now over in my model diagram over here. So we have our original Firefox running here, and we have the second Firefox running right here. Take a look at it and see. This Firefox number 1 is on one port address, and the other Firefox, the new Firefox, is on another port. And over on the server machine on our Raspberry, we have our original HTTP. You can see that our HTTP Python server is listening on port 8000, and the Nginx web server is listening on port 80. So the first Firefox we started is making a connection to port 8000, and the second Firefox we started is making a connection to port 80. In this way, the first Firefox traffic is going like this, and the second Firefox traffic is going like this. So this is how the two computers distinguish and multiplex the traffic to different applications at the application layer.